Good morning, champs. Today we are starting a new topic in statics, centroids. The centroid describes the geometric center of an area. For a uniform thin plate, it is also the point where we can imagine the entire area being concentrated when we are only interested in its geometric distribution. For our first example, we will deliberately use a very simple composite shape. The plate consists of a rectangle and a right triangle attached to its right side. The rectangle is 4 meters wide and 2 meters high. The triangle has a base of 3 meters and the same height of 2 meters. We choose the origin at the lower left corner of the plate. Our goal is to determine the horizontal and vertical coordinates of the centroid. The main idea is surprisingly simple. We split the complete area into shapes whose individual centroids we already know. First, consider the rectangle. Its area is 4 times 2, which gives 8 square meters. The centroid of a rectangle lies exactly at its center. Therefore, its horizontal coordinate is 2 meters and its vertical coordinate is 1 meter. Now consider the triangle. Its area is 1/2 times 3 times 2, which gives 3 square meters. For a right triangle, the centroid lies 1/3 of each leg away from the right angle corner. The triangular part begins 4 meters from our origin, so its centroid lies 1 meter farther to the right. Therefore, its horizontal coordinate is 5 meters. Its vertical coordinate is 2/3 of a meter. Now we need to combine the two shapes. A common mistake would be to simply take the midpoint between the two individual centroids. But that would ignore the fact that the rectangle has much more area than the triangle. Instead, the total centroid is an area-weighted average. This means that shapes with more area have more influence on the final centroid position. To calculate the horizontal coordinate, we multiply each area by the horizontal position of its own centroid. We add those contributions together and divide by the total area. For our example, this gives 8 times 2 plus 3 times 5, divided by 11. The result is approximately 2.82 meters. We do exactly the same thing in the vertical direction. The rectangle contributes 8 times 1. The triangle contributes 3 times 2/3. Adding these contributions and dividing by the total area gives approximately 0.91 meters. So the centroid of the complete plate is located 2.82 meters from the left edge and 0.91 meters above the bottom edge. Now we should always perform a quick physical check. The rectangle contains most of the total area, so we expect the centroid to remain relatively close to the rectangle. The triangle adds area on the right side, so it shifts the centroid to the right. Because much of the triangular area lies lower than the center of the rectangle, the vertical centroid also moves slightly downward. That is exactly what our result shows. The general procedure for composite areas is always the same. Choose your coordinate system. Split the shape into simple areas. Determine each area and the location of its own centroid. Then calculate the area-weighted average in the horizontal and vertical directions. The most important idea from this first example is simple. The centroid is not just the average of several points, it is the average position of the area, and larger areas have more influence.